So we'll continue now. Good. So what we'll do in this session is just to go through some examples. I'll show you some bigger examples of code just to get an idea of seeing these techniques. We have done, if we look at the reference manual, I probably won't. The two things we haven't done are the error guard, and I'll just tell you what happens here, rather than so it'll be quicker. But in Dyalog you have error trapping. You can say, if I get a domain error is an error 11, and a file name error is an error 22, I happen to know. So one of the things I can do in a dfun is to, within my braces, I can have code, and then I can say, if I get a file name error, double colon, then return bad file. And then I can try to quad ftime and what happens is this error guard is in effect for everything downstream of here. So if an error 22 is generated, or an error 0, which means anything, if there is any error, return immediately with whatever expression this is. So that's just very simple error trapping in Dfns. Okay, and I'll show you, we'll see some examples of that in a moment, so it's easy to see that. And then the final thing is sometimes, I can't think of an obvious example, but Dyalog has this concept of a shy result, where the result, the main raison d'etre of the function is to produce a side effect, like create a file, and the result of maybe how big or tire file, the result may be how big the file is or something, but it's a little, you don't really want to display that in a session. So what you do there is you have a guard that evaluates to true, and this could be anything that evaluates to true, and the result expression and the way you make it shy is to put an assignment here. So if you have this combination, a guard which evaluates to a 1, an expression evaluating to one guard, and then a name assignment, then it makes the result of this a shy result. And I'm just throwing that in. It's a rather obscure corner of Dfns, but what it means is we've covered the whole. That's all there is. There is no more to tell you about them. So all we do now is to go through some examples. Any questions? Yeah, let's see some examples. So the first example, so I'll show you some real Dfns. What you might want to do is to load the DFunctions Workspace. I have one in temp. Okay. This is available on the internet as a download. If I was clever, I could. Let me go back and see. Okay. Let me recommend to you. There's the DFunctions Workspace is a workspace that is now 13 years old. It started off in 1997, and it's accumulation of examples of programming in Dfns submitted by all sorts of people from everywhere, and I edit those. I just collect these and produce the examples. And the Dfunctions Workspace, dfns.dws, big dot. It's a workspace that's supplied with the product. So on this installation stick, there will be, you can load Dfns. And so what happens is somebody will send a nice little example in. Here's a good Dfn for doing something. And I write some I'd save it in the workspace, maybe write some notes, put a test script in with some examples and save it. And then I push a button on my computer, and that does two things. It uploads the code and the examples. It generates HTML pages, which it puts on up on the Dyalog website, and it generates a PDF document. So if you, let's just write this up in one. If you set your web browser to, this is a really good source of examples. www.dialog.com/. How do we get advice on this? DWS, all one word. So if you go to there, you see this page, and this is a top page for all of the examples. So it's actually a web. It should correspond exactly to the Dfunctions Workspace which is supplied. So you can either load the Dfunctions and play with it, or you can just browse it on the web. One of the things, for instance, if I click on here, there's a content, and then there's quite a large collection. As I say, this is examples that are classified, and they've been submitted by people at the bottom, thanks to a whole collection of people who've put stuff in. And if you, I think if you Google for another thing to do, you can find stuff in here by Googling Dyalog space and then something. So if you Google Dyalog space Bob Smith, you'll find Bob Smith's wonderful word wrapping algorithm that uses Domino. There's a huge collection of good material in here to experiment with. Okay. So, for example, I'll go back. Example here. I recommend it's probably more use to you than coming on to this session is to. So, for instance, here there's a display function. So in the Dfunctions Workspace there is a function, and then there's some notes, which is, for instance, these are all of the notes about this function. And at the top of each of the notes, I can click on, in fact there are 3 display functions here. If I click on the name of the function, it shows me the Dyalog code, the D code for this, and I'll go through this one. So this is the display function is the thing that draws boxes around nested arrays. It is a significant amount of code to write. You have to do recursion and fitting boxes together. This is it coded in D, and then at the bottom of each of these is a test script. So this is the regression test script. Oops, it's not very good font rendering there. There's a strange font character. So this is a test script which is run in the Dfunctions Workspace just to check everything is okay. So you can access everything from the website. So if I actually go back to the Dfunctions Workspace, we can see exactly the same thing. If I do tree, effectively I get, that's a Dfun. So this is a map of a workspace map. This is all, the stuff with down here is a function. So all of these are Dfunctions. These are examples of Dfunctions in this workspace. The things beginning with a jot are operators, D operators. So there's some examples of those. And then there's a notes namespace, notes, and this squiggle means it's a variable. So the notes for each of these, and then these are test scripts. So for example, I can edit the display function and see the function itself, which I'll trace through in a moment, or I can look at notes.display and see the same notes that I saw in This is just a character vector. Same notes that I saw in the on the web page. This is within the editor in a session, an APL I'm in an APL session. Let me just check that. Yep. Okay. And the other thing I can do is to edit. And this shows me the test scripts. And there's a function here saying test display. Yep, no news is good news. Test. Got an L4. Test this test scripts worked. Why didn't that work? Oh, test down. Perhaps it's test down. No, I've cocked something up. Sorry. Pretend that didn't happen. Test display does this, and if I want to see it running, if I put a 1 as a left argument, it says use the verbose option, so I can see the script running. That's all there is. So in a workspace there's functions, notes and test scripts. So let's just look at one of these, a display function, and I'll show you how this... so display, let me do display of... In Dyalog, the iota function will take a vector argument and produce a nested result. So this is the nested array, but if I do display of it, I see the nested result. So one of the things I can do here is to trace it. Can you read that? Can you read the characters? And we'll just go through line by line and pick out some points. Let me just show you, display is actually ambivalent. If I do the 1 display, I get this, and if I do the 0 display, I get clunky box characters, because in the old days it was impossible to print nice smooth line drawing characters, so people liked clunky characters. So it defaults, if I don't put anything, it defaults to smooth characters, but if I want clunky characters I can use a 1. Yeah.
Do you do anything like Ravenhorse original design?
So you
Do you do anything like Ravenhorse original design?
Oh yeah, I think there's a display R. Is that that?
Yeah.
And there's a display S, which I don't know what that display. Sorry, that's another slightly different. I don't know what that is. But again, they're written up in the notes in there. So if you Google for display S, you'll get those. You'll see the notes. Okay, but let's just use the. Here's a Dfun in action. So I'm going to trace this. Now, the first thing is you'll see on the top line I'm setting quad IO and quad ML to 0 because it's easier to code in that. But we've seen that I can just assign names, so system names are no different. You remember when I had the vector which was sum is assigned plus slash omega. I'm just doing assignments here. So one of the things I can do, here's a trick to show you. If I go to my session and say what is the state indicator, it says I'm on line 0 of display, and if I say what's the state indicator with the name list, there are no names. If I execute that line and do it again, I've now defined 2 local names in the Dfun at this point. So my name list now has 2 names. And we saw that the name assignment is dynamic. So it just makes new shadows, makes new names. Right?
Does that require parentheses around it?
No, and I think we blame the original NAS for that, which yeah. yes, the question Bob's asking is whether if you do multiple name assignments, in APL 2 you are obliged to write it like this. And Dyalog chose not to do that because in Dyalog you can, if you want to assign A to 2 and B to 3, then you can write it like that in Dyalog. In APL Sharp we will insist on the parens. In Dyalog it's optional, you can put the parens in, it makes no difference. Okay.
But you need them for complicated stuff inside.
Yeah. Okay. So what we see, actually there's got time for a joke. One of the things that I'm fond of saying there's two types of people in the world. There's those that say we assign A to 3 and the others that say we assign 3 to A, and you can decide which one of those kind of people you are. Ken Iverson, last time I heard him speak, pronounced this A specifies 3. So you can judge your way around. But the joke is that a lot of APLers say assign 3 to A because that's the way if this is an arrow, that's the way it points. The functional programmers, and I like to try to think of this, tend to think of it the other way around. They tend to assign a name to something. And if you go to a baby naming ceremony, like a christening in Christian religion, I believe you assign the name to the child, not the child to the name. So there's a good precedent for that. And so I like to think of this is a joke, I like to think of this glyph as a right pointing finger rather than a left pointing arrow. So A indicates 3 after this. Yeah. So, okay, that's end of some. So what we can see on the next, if I go over to the next line, then we can start seeing the things we've learnt about. Alpha assign 1 means we want to default to 1, so we want to default to smooth characters, and we discussed that. If alpha is not specified, give it a value of 1, and then I can use it to, although it's hard to see, this is a 2-item vector. There's one bunch of smooth characters, and there's a bunch of clunky characters. So if alpha is 1, we choose the smooth characters. We're working in origin 0. If alpha is 0, we choose the clunky characters. So that's that dealt with. And now I can name each of these characters, top left, top right, bottom left, bottom right, vertical and horizontal characters, either clunky or... So I can forget the clunkiness from now on. And if I go over here and SINL, now we have more local names we defined. Yeah, so I can say what's the top left character and the top right. Yeah, so these are the characters we're working. Now the next thing is this is a dfun between those braces because it's in braces. It's just a D function, and I'm naming it. So if you watch very carefully, if I trace over this, it goes to there, and then I've defined a new name. It's not executing this code, it's just naming it. So I'm defining a nested inner function. And let me see if there are any. In this one, there are no nested functions, but you can nest functions as deeply as you like, up to the infinity or 255, I think, is as deeply nested as you can go. So what I've done here is to make one more name. So there's now a box. It pushes them on the front of the stack. Here's the new Neat John Dangerous umbrella, the new the new name. So each of the following lines is just defining a little, each of these you can see is just naming another dfunction. So what we have is dfunctions within dfunctions. We're just naming. Yeah. So the display function is very nice. We can have little local, and these names are all local. So define a function, define a function, define a function, define a function. And this function type calls char each, where char is defined down here. So the functions, this function up here calls axes, and axes is defined, where's that defined? Somewhere else, down on the next line down. So you can effectively make a whole little microcosm of code all nested. So now we've defined all of the names we need, and here we have a d function. You can see between this parenthesis and this parenthesis, sorry, brace and brace, and there is another difference. We don't need to name this, we're just applying it to an argument. So this is an unnamed, there's no need to give it a name because we're only going to use it once and throw it away. So I'm going to apply this, I'm going to trace into this, and now we have a guard. If omega is depth 0, then we're done. This is the result. Otherwise, we have some very strange animals in Dyalog. This is a quad OI. It's not one of those. Otherwise, if the depth is 1, it's a simple array, and we're done. Otherwise, and this is the default case, there's no guard here. The result of the dfun is the result of this expression. So at each point, we've said the result of the display initially is the result of this. How do we determine that? Then we apply it, and we go through this line. So now the result of the dfun is the result of applying this little function. The del refers to the enclosing dfun, which are these braces. So the way the interpreter works is going to apply this function recursively to each of open of omega. And open is the display function was who invented it? Was it Rabenhorst? Who wrote it? Many years ago. The display. Sorry? 1988. I think he worked for IBM. He was an IBMer who designed this function. So we just took that design and implemented it. And one of the things, let me just come back a moment. In a display function, if I have an array like this, hello. Let me display this. Let me display the enclose of this. If I don't use the display function, if I say the 0 reshape of the enclose of this, then I don't see anything. But if I display the 0 reshape of the enclose, display pops out the prototypical items of the, it's just the way display is defined. It tells me here that I'm dealing with a null vector, the 0 reshape, but its prototypical item is this 2-item vector whose first item is a bunch of blanks and whose second item is three zeros. So the display function is defined to expose prototypical items of null arrays. And if I go through, let me just quickly get to here again. So in this case, omega is this, and open omega is that. But open, if I type open iota 0, it's just open. The job of little subfunction open here is to open a null array to expose the prototypical items. And typically that can be just the one max shape of omega, reshape of omega, but we have to do a little bit more work if it's a Dyalog ref. It doesn't, the prototypical items are refs, a little bit more demanding. So this is an error condition. It tries to do this, but if I get an error 16, which is I think a nonce. Oops. Nonce error. So this is an example of error trapping. It traps nonce error, and then it tries to expose the prototypical item. If it gets a nonce error, then it's a ref to a namespace, which we haven't defined the prototypical item yet. I don't know if you thought about that, Bob. If that's okay. Then we just say ref in brackets. So that's the open. But that's a good example of the error trapping. If I get a 16 error, then this is a result of the function. Otherwise, diamond is just the same as new line. Then it's just this one max row omega. Effectively, that's if there are any zeros in the shape, then we substitute ones for them. Okay. So what we're doing in this line here is we're opening omega and then applying this function recursively to each of the items in it. So we'll go around. So we're going to say it's not depth 0, it's not a quad OR, it's not depth 1. What am I doing? Display iota 2. Right, let's go around again. So go here. Right, so it's not depth 0, it's not a quad OR, it's not depth 1. So I'm going to call this recursively for each. So omega at the moment is this. And when I call recursively, omega is 1, 1 this time. It's going to recursively apply this function to each subarray. So this time, is it a simple array? Yes, it is. I'm going to open it, format it into a character matrix, open that in case that's null, and then box draws a little box around it. So when I trace this, I'm applying the box function, and this figures out, this is the sort of hard bit, this figures out how many this figures out all of the little line drawing characters to draw around this box. So this is a good example. You can see each of these is a definition of a name local to this box function of the various arrays, and then at the bottom I can experiment with this in a session. I've got omega is this, so omega, I'm not used to this keyboard, so excuse me, I could do with a Dyalog keyboard. Omega comma right is that. Oh, comma, sorry. Omega comma bot, I mean. Is that. Top comma is that. If I put left comma, so we can see this being built up in a session. Yeah? So that's the result I want to return. So this is the result of this function. There's a mantra. Did I write the mantra? Hang on. This is a Dfn is an expression preceded by 0 or more local definitions. So in this case, we can see here's the expression, and it's preceded by 0 or more local definitions used in that expression. So when I hit enter on this, because I'm applying this recursively using each, I should see it go through this box function 3 more times. So So each of these are all the different, and again, the last time it should go through with 2, 2. And so this time, this function will return its result. So this each function will complete. It will format that into a character array. Trim takes out some additional blank columns, and then it's got to box the whole thing. So if I hit enter now, it will go into, oh, hang on, it ran away with me. Let me just do this one more time. I have a bug in I have a bug here where it's, let me just do this one more time. There's a bug which we've attempted to fix, but it's not fixed in this release. Box 1, 2, 3, 4. Yeah, okay, and this time the omega is this, so I now need to just box this last thing. So I'm drawing a box around this, and that's the result. Okay. So we've actually seen most of the techniques we've used brought together in a substantial defun. Right. So I'd suggest if you want to Google, you can find many more examples. If you have some examples, you find nice examples of Dfns. If you send them to the Dfns forum or email them to me, then I'd appreciate new examples if they're not already in there or something very similar. So what I'll do is to conclude, and then see if there are any questions. So Dyalog Dfns are a different way of collecting our APL expressions into defined functions. They are functional as opposed to procedural way of thinking about things. And the way you can tell whether you're thinking, well, there's some good jokes in here as well. Declarative program. If you're thinking in a declarative fashion, let's see. What's that? There's some good jokes if you can find them. Here's a joke. You don't need to read all of this, but this is saying you should try to program in a declarative fashion. If you do that, when you arrive at the pearly gates, there's a fast track for people that think in a declarative fashion. You can look that up yourself. Okay, so it's the way of using. And what we've tried to do is we have traditional functions and Dfns. If you, Morton mentioned this, tomorrow I'm going to give a presentation which tries to show you how we're going to merge these two very different styles into a single function definition style for APL sharp. And you can come along and see if you think we've done a reasonable job, or whether it just looks like a camel, 2 bits bolted together. So thank you for your attention. Any questions? So let's, okay, well, come and find me. I'm here all week, folks. Come and find me in the if you have any examples. Thank you very much. Thank you.